This is Mr. Hassan's Maths channel, and I'm now going to be answering question number 11 from the October-November 2020 Pure Mathematics P1 paper. This is paper 1, variant 3. This is from the 9709 Cambridge syllabus. And this question is about circles. So it says a circle with center C has equation x minus 8 squared plus y minus 4 squared equals 100. Show that the point T, negative 6, 6, is outside of the circle. Right, so now we have a question about circles. And one of the things that we should understand is that when we have the equation of a circle written in this form, x minus a squared plus y minus b squared equals a number squared, which happens to be the square of the radius, then the center of the circle is going to be given by the x value that makes this x bracket 0, which is going to be, in this case, a, and the y value that makes this bracket 0, which is going to be b. So that's those are the coordinates of the center, those two numbers there, with the opposite signs. And the radius is r. The radius is the square root of this number here, and that's how we can understand finding the the center and the radius of a circle. And a lot of students ask, why is this the case? Why is it that it's the opposite number in these brackets? So what I'm going to do here, it's a little tutorial kind of thing. I'm going to just explain to you exactly the reason why. Okay, so it's you don't need to know this really, but you can memorize that, but it's always good to know why. So supposing I have a circle, and say the center of the circle is somewhere not at the origin, somewhere away from the origin, somewhere over here, for example. So supposing this is the center of the circle, okay? And this is the center right here. And the coordinates of the center of the circle are A and B. So let's call this A for the x coordinate, and let's call this B for the y coordinate of the center of the circle. Now, if we have a point, for example, P, which let's say I draw it over there. This point P has coordinates, let's call it xy, in general xy. Okay, and we can see this is the radius of the circle. Now, what I can do here is I can draw a right angle triangle in this circle from the radius down to the center like this. Okay, this right angle triangle here. Now, this is the radius of the circle. Okay, the radius of the circle. Now, this length here, okay, now we know that up to this point you've got B. So you can think of this length between here and here is B. Okay, and the length between the y-axis and this point here that's going to be A. So that's A and that's B. Okay, so if I want to find what the length of this side of this triangle is, okay, the length between these 2 points here, I'm going to find that length there. Well, that length is going to be the distance between P, where P is vertically, okay, which is going to be, this is like the y value, this is y, this is the y coordinate of P because it's vertical, and this is going to be from here to there is B, so this distance is going to be y minus B. So this length is y minus B, the length from there to there. And similarly, we can say that the length between this point and this point here is going to be the x coordinate of P. So this is going to be x, and this distance is A. So the length between these 2 points here is going to be x minus A, right? So that's y minus B, and that's x minus A. So if we use Pythagoras' theorem on this right angle triangle, we know that the sum of the squares of the two shorter sides is equal to the square of the hypotenuse. So I can say x minus a squared plus y minus b squared is equal to, oops, what happened there? Plus y minus b squared. Just get that back to normal again. Y minus b squared is equal to r squared. Okay, so that is basically the equation of the circle, right? And we can see that the coordinates of the center, okay, of the circle are positive A and positive B. Okay, we can see that. That's the center of the circle, AB, right? So we don't actually have to know this, but it's something that might help us, okay, when we are going through this. Okay. As I said, we don't really need to know this. I'm going to get rid of all of this stuff now. It's just for those students who want to know the reason why. We write the opposite of each of those when we are finding the center of the circle. All right, so now, so for this particular circle, we can see that the center C is going to be, the value of x is going to be 8, and the value of y is going to be 4. So that's the center. And we know that the square of the radius is equal to 100. Therefore, the radius is equal to the square root of 100, which is 10. So this is the center and radius of the circle. So we got to show that the point T, negative 6, 6, is outside of the circle, right? So basically what we can understand from this is that we have the center of the circle. Okay, so I'll just make a little sketch just to illustrate. So if we have the center of the circle over there, now the radius of the circle is 10. Okay, the radius of the circle is 10. And the center of the circle is 8, 4. So if T is somewhere, or the distance between T and C is more than 10 units, okay, because it's the center. If T is somewhere out here, then of course T will be outside of the circle. So if the length of TC, so we can say if the magnitude of the line between T and C is greater than 10, then T is outside the circle. Okay, if it's less than 10, then it will be inside the circle. Okay, so if it's equal to 10, it will be on the circle, right? So that's what we can understand from this. All right, so let's work out the length of TC. Now we know T has the coordinates negative 6 and 6. So we can find the length between T and C by using what's called the length formula, which is basically Pythagoras' theorem applied to these points. Okay, so let's say T is over there somewhere. We know that it's outside the circle, so I'm going to draw it like this, but we have to just prove it. So what we can see here is this is negative 6 and 6. So I can see that this length here, this length here is the change in the x values, and this length here is the change in the y values. So we can see that if I take away the x values, I'll have 8 minus 6, 8 minus, okay, minus 6, and that's going to be squared, plus, and they're going to have 4, so 8 minus 6, and they're going to have 4 minus 6 for the y values, okay? So I have 4 minus 6 for the y values, and that's going to be squared, all right? So that's the distance between those, okay? So we can see that this distance here is going to be basically 10 units, 14 units, and this is 2 units. So we're using Pythagoras. This is exactly what it's going to give us. That's going to be the square root, basically, of 14 squared plus, and that's going to be minus 2 all squared, which is the same as 2 squared, which is going to give you, I'll write it as 2 squared, it's going to be 4. So that should give us our answer. So we have the square root of 14 squared plus 2 squared, which gives us 10 times root 2. Of course, 10 times root 2 must be bigger than 10. So as the magnitude of TC is bigger than the radius, okay, and we can say 10 root 2 is greater than 10. Therefore, T must be outside of the circle. outside of the circle. Okay, so that's a good enough proof. We could also prove it in another way, because I know that the furthest that we can go is 10 units from C to the left, horizontally. So the lowest x coordinate for any point that would be inside the circle, the lowest possible x coordinate is going to be 8 minus 10, which is minus 2. Okay, so this point would be minus 2. And you can see the x coordinate of t is minus 6. There's no way that t can be in the circle. So we could also write the proof in that way, mentioning that fact by doing the following. So let's just see how we could write that in a nice way. We can say that the distance between C and T, okay, the distance between C and T, okay, horizontally, we can say it like this. The x coordinate of C, okay, minus the x coordinate of T, is equal to, it's going to be 8 minus 6, which is 14 units. And we can see that the lowest x value of the circle, the lowest x coordinate of the circle must be 8 minus the radius, because you're going to have 8 minus the radius. That's the lowest it can be, which is going to be minus 2. Okay, so we can see here that basically, t has a coordinates. The x coordinate of t is equal to minus 6, which is less than the lowest value. So we don't actually have to mention this part at all. We can mention the lowest x value of the circle is 8 minus 10, which is minus 2. That's the lowest x coordinate of the circle. And we can see that the x coordinate of the point t is negative 6. Okay, so we can say that x coordinate of t is equal to negative 6, which is less than negative 2. Therefore, you can say that t must be outside of the circle. Must be outside of the circle. We could mention that also. Okay. So there's the answer to part A of this question. Now we're going to move on to part B. So we have two tangents to the circle are drawn. Show that the angle between one of the tangents and CT is exactly 45 degrees. Okay, so now we know that the center of the circle, as we said, is 8 and 4. And we know that the radius of the circle is 10, as we mentioned from part A. So we got to show the angle between one of the tangent and CT is exactly 45. Okay, and we also worked out that the length of CT was 10 times root 2. So that information should help us here. So what I'm going to do to illustrate this, to make it very clear, and which something that I would suggest that you should all do in your exam, make a clear diagram. When you got circles question, always make a clear diagram. And I would suggest you even take a compass, okay, into the exam with you, all right? A compass, like from a geometry set, the one with a point, you can make a circle from it. And that will make your diagram a bit more kind of like, neater. It's very difficult to draw a circle freehand, okay? So I would suggest you do that for the P1 exam, because if there's a circle question and it's a question where you want to visualize things, it's good to actually draw it. So I'm going to just make a rough kind of sketch here. So 8, 4, let's say 8, 4 is somewhere over here. Okay, it's just a rough sketch. 8 and 4. Okay, and we mentioned that the lowest value you can reach is a negative 2. Okay, because the radius is going to be 10. So the lowest value in the x is going to be negative 2. So let's say it's going to be something like this. Come out a bit bigger than I expected, but no problem. So it's going to be something like this. Make it slightly smaller because I want the furthest it reaches is going to be 2. So I'll keep that at the center best as I can. So it's going to be something like this. That's the furthest it reaches on the x value, negative 2. Okay. So this is the center of the circle, which is 8, 4. Now, the coordinates of t is -6, 6. So it's somewhere up here. Somewhere up here. Okay. So what I'll do is I'll lower this down slightly so that it's down a bit. Okay. Now, what we can do now is the following. We know that at -6, 6, which is somewhere up here, -6, 6, somewhere around here, there's a tangent to the circle. So I'm going to draw the tangent first so that it makes it a bit clearer. So I'm going to draw the tangent to the circle. Okay, that's going somewhere over here. There's another tangent on this side. Two tangents to the circle. Okay. And the angle between them is exactly 45. Okay, between those and CT. So now that means the angle between these two must be 90 degrees, because when you have two tangents, like if you have a circle and you have two tangents to the circle like this, and you draw a line between the point where the tangents start and the center of the circle, then these two angles will be the same. So if the two angles will be both 45, then this must be 90 degrees. So I'm going to try and draw this such that we end up with a 90-degree angle here, because that's exactly what it's going to be. You're going to end up with a 90-degree angle over here. So something like this. Okay. The angle between these two, that's going to be 90 degrees. How do we know? But we have to keep it up here somewhere. So let me try and do it this way. That's better. That's a bit better. Yeah, that's better, because it has to be at 6. So it's got to be slightly above. So I'm just trying to make a diagram that makes it clear that what we're doing. So this angle here is going to be 90 degrees. Why? Because if this is T and this is C, we have to show that the angle between one of the tangents and CT is exactly 45. So we've got to show that this angle is 45. That means that angle is going to be 90. Okay, so I'm just drawing it so it's a bit more accurate. So I know that if I join the center to the place where the tangent meets the radius, one of the laws that we learn about circles and tangents to the circles is that the tangent meets the radius at the point where the tangent starts the circle at 90 degrees. So that's definitely 90 degrees. So I know that the radius of the circle is 10. There's 10 between those two. And I know that CT is 10 root 2. Okay, so the length of CT is 10 root 2. And I've got to find this angle, which I'm going to call theta. So I have like a right angle triangle like this. I have a right angle triangle. Okay, and I want to find this angle. I know that this is 10. I know that this is 10 root 2. And this is the right angle. So I can use trigonometry. I know that this is opposite, this is the hypotenuse, so I can use a sine ratio. So I can say that the sine of theta is equal to opposite, which is 10, over the hypotenuse, which is 10 root 2. The 10s will cancel out, leaving with sine theta equals 1 over root 2. And that is one of the exact values of angles that we should know is going to give us 45 degrees. If you're not sure of that, you could have just straight away put that into your calculator. You could put shift sine of 10 divided by 10 times root 2. And of course, that's going to give us 45 degrees. But we have to be in degree mode. So let me just change that to degree mode first. So angle unit degrees. Then I press equals. It's going to give me 45 degrees. So we have shown that it's 45 degrees. So there's the answer to that question. So having a diagram helps you to visualize what's actually going on, and it helps us to be able to answer the question in a more kind of efficient way. So this was the y-axis that I drew here. We don't have to really worry too much about that. Okay, so there's the answer to part B. Okay, and now we're going to do part C. The two tangents touch the circle at A and B. So I've got the diagram from the last page is copied. So let's say this is the point A, and let's say this is the point B. Okay, that's where the two tangents from the point T touch the circle. So we've got to find the equation of the line AB. We're going to find the equation of the line AB, which is this line between those 2 points, between where the two tangents touch the circle, right? Now, one of the things that we should realize here, which will really help us, is first of all, is that we need to find the equation of this line. We don't know the coordinates of A and B. However, we should understand that as this is a right angle, and this is a right angle, and as this is, if this is 45, this is 90, this is also 45. They're both 45, this angle over here. So this is an isosceles triangle. So this length is equal to that length. So this is 10. So if these are both right angles, okay, then these two lines are parallel. And then that, and also we can see that this line, if we join this to this center to there, this is also going to be, if that's 45, this is also going to be 45. So this is going to be 90. And this is going to be 90 as well, because it's a tangent meets the radius. So what we have here is a square. What we have here is a square because these sides are parallel to each other and they're the same length. So all these sides are 10. This is actually a square. Okay. So this ACBT is a square. ACBT is a square. Now, how does that help us? What we know about a square, one of the properties of the quadrilaterals, and this is actually a bit of a, a tricky question because of this. So we have to remember some of the properties of quadrilaterals that we learnt in IGCSE. That when you have a square, the diagonals they bisect each other. Okay, so basically, this point here, okay, is the midpoint of CT. Okay, so I'll call it M. Is the midpoint of CT, and it's also the midpoint of AB. Okay, but because I know the coordinates of C and T, that will help us. All right, and so we know the coordinates of C, as we said, was the center of the circle was 8 and 4, and the coordinates of T was -6 and 6. Right, we were told that already in the question before, and so we can see that the point M is the midpoint of CT. So if you want to find the equation of the line AB, again, I need two things. I need to find point on the line, which M is going to be a point on the line, which we can find its coordinates. And we need to know the gradient of the line. Now, the other thing we know about the diagonals in a square is that they bisect each other at right angles. So this is a right angle. So we can say that the gradient between A and B is perpendicular to, this is the symbol for perpendicular, to the gradient between T and C. Okay, so therefore I can find the gradient of AB. I know that the point M, okay, lies on AB, so I can find the equation of the line using that fact. So first of all, let's find the midpoint. The midpoint is going to be the average of the x coordinates. So you have 8 plus -6 divided by 2. That's the x coordinate, and the y coordinate will be 4 plus 6 divided by 2. So the midpoint is going to have coordinates. That's 8 minus 6, which is going to be 2. 2 divided by 2 is 1. 4 plus 6 is 5. So it's 10. 10 divided by 2 is 5. So the midpoint is going to be 1, 5. Okay, now it's not drawn very accurately, so that's why it looks like it's actually on the negative side, but it's not actually drawn that accurately, because we can see that that's the point T is -6 and this is 8, so we can see that halfway between them is going to be positive 1, so we can see that, right? But it's very difficult to draw this accurately. It's not drawn accurately, just to give us an idea of how things are, so that's fine, no problem with that. And we know that the gradient of CT is equal to the change in y between C and T. Now, the change in y between c and t is going to be 4 minus 6 over the change in x, which is 8 minus 6, which is going to be minus 2 over 14, which is negative 1 over 7. So the gradient of this line is negative 1 over 7. Therefore, the gradient of our line AB is going to be the negative reciprocal of this, which is going to be 7. So we know that these are the important points. That's the gradient of the line AB, and that's the point on the line AB. So I can use now my equation of a straight line, y minus y1 equals m times x minus x1. So y minus 5 equals 7 times x minus 1. So I've got y minus 5 equals 7x minus 7. Now they did ask us to write it in the form y equals mx plus c. So in the end, you have to write y equals 7x. You've got to add 5 to both sides. So it's going to be minus 2. So there's the answer. Now, a lot of students don't like to use this y minus y1 business, but I would recommend that you do use it, because later on it will make life easier for you when you have more complicated kind of questions. But just for those of you who are not really that familiar with it and you prefer to use y equals mx plus c, here you just put the y coordinate of the point, the gradient, the x coordinate of the point, and that finds the y-intercept for you. So 5 equals 7 plus c. So therefore c equals 5 minus 7, which is negative 2. So then we write y equals m, which is, as we worked out, is 7, x minus 2. So those are two ways of answering that question. And that's the answer to part C. Now we have to find the x coordinates of A and B. So we need to find now the x coordinate of A and B. Now there's a couple of ways we could do this. One of the ways we could do this is by using the fact that a line and a curve intersect. Okay, so if we can see where the line AB intersects the circle, right? If we try to find where the line intersects the circle, so we have the equation of the circle, which is x minus 8 squared plus y minus 4 squared equals 100, intersects with y equals 7x minus 2. We can find where they intersect by substituting the equation of the line into the equation of the circle. So what I can do is I can write x minus 8 squared plus, instead of y, I can write 7x minus 2. Then I got the minus 4 squared equals 100. So now I have an equation in x, and that will give me the two coordinates of x, of A and B. Right? So if I now solve this, I can expand this bracket. So that's going to give me, let's first just keep it at the same level. Let's simplify this first. That's 7x minus 6 squared equals 100. So if I square this bracket, I'm going to square the first term. I'm going to put the minus sign because there's a minus here. I'm going to multiply these together and double it. That's going to be negative 16x. Then I'm going to square the last term. It will be positive 64. Same thing here. I'm going to square the first term. That's going to give me 49x squared. Multiply them together. That's going to be negative 42x doubled is negative 84x. Square the last term. That gives me plus 36. And that's equal to 100. So now I have 50x squared minus 16x minus 84x. That's going to give you, that's negative 100x. And you've got 64 plus 36, which is plus 100, equals 100. So we can divide everything by, in fact, we can first of all, if we subtract 100 from both sides, we've got 50x squared minus 100x equals 0. Okay. And then we can basically here do what? We can divide by 50. So we have x squared minus 2x equals 0. So if you solve this, you have x times x minus 2 equals 0. So you can say x equals 0 and x equals 2. Those are the coordinates of A and B. Okay, they didn't specify which one is which. So for my drawing, what I've drawn, of course, x is going to be 2 and x. So it's actually they do hit on the y-axis. Okay, one of them, probably the B one is probably going to be hitting the x-axis. what I've called B. But anyway, I'm sorry, the y-axis. I mean, x equals 0 is the y-axis. So I haven't really drawn it that well, but it doesn't matter. We got the idea. We don't even have to draw, but it really helps you to visualize. As you can see, this question is much easier to visualize when you draw. Okay, so we could have worked this out in some other ways. Okay, but I think this is probably the easiest way to deal with it. Okay, where you find where the circle and the straight line intersect by solving the equations simultaneously. Okay, so that concludes this question. This was the last question on this paper. It was a bit of a tough one because you have to remember some of these properties of circles and of quadrilaterals. So all of these things, especially in these circles questions, do come in. So something that we have to review, and the more questions we practice, hopefully the more we'll be able to review those kind of concepts. So if you want to see other questions from this particular paper, you can click on the link at the end of this video, which will be in this area over here. That takes you to the playlist for the paper. If you want to see questions to do with circles in P1 of Cambridge, you can see questions from this playlist over here. I'm also going to give you a link to the Edexcel material that I have on circles, which is in P2 of Edexcel, because there is a limited number of questions from the Cambridge syllabus as it just started in October, November 2020. So you'll see there's lots of questions from Edexcel from way back, and I've got many questions answered. So that playlist will help you to see some of those questions. They're very similar to the ones you get in Cambridge anyway. So that will help you to review this topic, more deeply. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.